Good evening, everyone. This is Group 7. I'm Manasa. We are a team of 5 and we have Shaleen, Maunisha, Nikhil, and Prithvi on our team. Our project ShoreSync is a web application designed to augment the data collection efforts that is crucial for shoreline management. Data collection for shoreline management plays a crucial role in understanding shoreline stability, which can be affected by soil erosion due to rising sea levels, storms, and flooding. When the shoreline becomes destabilized, water encroaches on the shorelines, causing loss of vegetation and impacting the local area. Therefore, data collection helps local and state bodies prevent destabilization by taking adequate measures such as constructing riprap walls, sea walls, bulkheads, etc. Additionally, data collection assists in understanding pollution from various sources. For instance, residential and commercial lands nearby can lead to higher levels of pollution in these coastal areas. In summary, shoreline management is essential to understand the existing conditions of the shore and to determine its future uses concerning ecosystem services, economic conditions, and the impact of climate change. However, the problem with traditional data collection methods for shoreline management is that they are time consuming and resource intensive, making it an expensive affair. Since there is a continuous need to update this data due to changing shoreline conditions, this process must be repeated periodically, which is a huge challenge in itself. Based on the problem statement, we need to design a web application that can augment the data collection efforts and that adopts a citizen science based approach for effective shoreline management, which is not only viable but also scalable and easy to maintain in the long run. For our project, we have successfully developed a citizen centric web application where users can upload multiple shoreline images and also select the various shoreline features that are relevant to the images they are uploading. We have also implemented the functionality to tag these images with geo coordinates. So, in each individual session, the shoreline data is selected and the shoreline images uploaded along with the tagged geo coordinates are stored in the database. To make our application user centric and easy to use, we have added several features like the tooltip functionality, toast notifications, option to go to the home page at any time, reset function, option to upload multiple images in a single session, previous and continue buttons, and so on, which will be discussed in detail in the demo.
Hi everyone, I'm Monisha, and now let me give a brief about the context and the background of this project. The Center for Coastal Resources Management at the Virginia Institute of Marine Sciences is tasked with maintaining a comprehensive inventory of tidal shorelines to monitor ongoing conditions. This data serves as vital baseline information to aid in shoreline management and enhance decision making for local and state governing bodies. Such datasets form the foundation for numerous modeling tasks related to climate change, addressing ecological and socio-economic aspects. The most recent shoreline inventory in Virginia spanned from 2012 to 2019. However, rapid changes in coastal areas, including increased development and the impact of climate change on coastal habitats, underscore the urgent need for updates. With appropriate citizen participation, the ubiquity of smartphone access, we will enable the individuals to contribute updated geo information that can be used to validate existing assessment approaches such as remote sensing based GIS models. To discuss about the project goals, this pilot project focuses on the shoreline of the Gloucester County where WIMS is located. It will involve designing and implementing a community survey to gauge public interest in using citizen scientists to gather shoreline data as well as finding a best way to optimize the data collection, entry, and validation processes. The project aim was to create a web application for the citizens of Shoreline to be able to submit data using multiple forms such as riparian land uses form, bank attributes form, shoreline features form, along with multiple images of the shoreline changes by tagging GPS coordinates.
The main function of a project is essentially a form that collects data about the riparian land use conditions, information about the bank attributes, and the shoreline features. The application retrieves the current GPS coordinates of the user to be able to pinpoint where specifically on the map these details are about. The user can also upload multiple images of their shoreline surroundings that the application would store in a database, along with the other data from the form itself. Additionally, we will have a login and logout functionality in order to ensure that the data we've collected can be saved to a particular user. In regards to our target users, our client is the Virginia Institute of Marine Science, who will use the database with the collected information from the form to make decisions and plans according to the shoreline trends they find with the data. Also, they will have a more updated database with current information rather than relying on data from several years before. The main users who will actually fill out the form and use the application would typically be citizens along the shoreline. We wanted to target these citizens in particular since they already had a familiarity with the shoreline and would also have a better understanding of the details we're actually asking for on the form. Also, since they live along the shoreline, they would be around the shoreline more frequently so they can fill out multiple entries for different locations if they can. Our solution is unique in compared to other solutions since we focus primarily on collecting data, while others have more of a way to visually view the data they already have. Additionally, our solution is more interactive and user-friendly, while others involve more manual effort. For our overall web application, we have a login and logout functionality involving authentication. This is important so that the database can have more information about who particularly submitted the data on the form. Our application also has a GPS coordinate retrieval functionality to get the exact coordinates the user is filling out the form at, and the user can upload one or more images of the shoreline into the form itself. We also have interactive reminders to fill out all the required questions on the page so that the user has a better understanding of why they can't go to the next page. Next, users can use the previous and next button to maintain their progress while also being able to navigate to a different page in case they want to review or change their answer to a question. Lastly, there's a tooltip for every answer choice or question where the user can hover over it to read a description of what the attribute or question actually means in case they were unsure.
Tools and technologies. For our front end, we used HTML, CSS, and React.js to develop the user interface. Our backend is powered by Node.js and Express.js, providing robust server-side functionalities. PostgreSQL server as the backbone for our data management. We utilized Compressor.js to optimize image sizes, enhancing performance without compromising quality. And we used Multer, a Node.js middleware for handling multi-part form data, which is primarily used for uploading files. This made it easier for users to upload multiple images. Then, Visual Studio Code was used as the primary integrated development environment IDE for coding and debugging. GitHub was used for version control and collaboration among the team members. Now, let's look at the issues we have faced in our project. 1. New tech stack. Transitioning to React.js, Express.js, and Node.js presented initial challenges, but we successfully adapted and leveraged their capabilities for our project. 2. Asynchronous challenges. JavaScript's asynchronous nature occasionally posed few difficulties, particularly in ensuring proper reporting of failures to callbacks. However, through thorough testing and debugging, we addressed these issues effectively. 3. Communication hurdles. Initially, managing communication was quite challenging due to different schedules among team members. However, frequent meetings and collaboration tools gradually enhanced coordination and clarity over time. Lessons learned or reflections. In hindsight, our project could have been benefited from improved story identification and grooming processes. We had to redo some things as we directly started the implementation, and it would have been a great practice to focus on analysis and design part first. Additionally, having a comfortable technology stack either on the front end or back end would have streamlined our development. Furthermore, effective communication played a major role in the success of the project. Now let's dive into our application demo.
Hello everyone, this is the demo for our application SureSync. First I'll go and show how to register for the application. So let's say make the application email as capstone123@gmail.com. For the same password would be this. I'll make sure it is same password. Now it is successfully signed up. Okay, now I'll use the same password for login, and login is successful. Now in the form, in the first form, user has to select the features of the shoreline application, riparian land users. So it will be, I'll select these three. And in the next form, user should select bank attribute features. So bank height, bank stability, bank cover, marsh buffer, beach buffer, and fragment australis. And finally, shoreline features like erosion control structures, what are the possibilities? And recreational structures, what are the other possibilities? And other, we can select it or we can unselect it. I'll make it unselected, and I'll press continue here. Now user has to synchronize the coordinates. So for synchronizing, when we click the synchronize button, we get the latitude and longitude of the particular user location, and here one can upload the images. So for example, I'll upload this. Now when I user plus final submit data button, it goes into submit mode, and it will redirect to the original page after submission, and all the session data token is also removed. When user press logout button, it goes out of the application. Now I'll show again to the final thing. If email ID already exists, then user won't be able to log in. It says registration failed, please try again. Yeah, so this is our application. This is a short demo of the application. And again, if users want to go to login page, you can simply go backward, and you can log in again into the application, and you can proceed with other details. Yeah, thank you. Apart from that, we also added tooltip for each and every variable here. Like for example, when a user hovers on the tooltip of the forest, he can understand what is forest actually, residential, what is residential, and similarly for other details, he can actually go and check what is bank head, what is bank stability, and bank cover, etc. And when home button is pressed, user can directly go to home. Also, we added links for Center for Coastal Resources Management and Virginia Tech, and also the other stakeholder, Virginia Institute of Medical and Sciences. So yeah, so that's it for our demo. Thanks for your valuable time. See you.
Here are our contributions. Monisa worked on the backend login functionality, development on the front-end UI, and the creation of the tables in the database. Monisha worked on the front-end GPS functionality, the backend, and the database. Nikhil worked on the UI development and the integration on the front end. Prithvi worked on the front-end UI development, data collection, and the database, and Shalene worked on the front-end development as well, and data collection of the form and image compression.
We, Group 7, would like to thank you for your time